In this video, we're going to learn about translations. Sometimes you'll hear a translation referred to as a slide. Mathematically, a translation is a rigid transformation that slides a figure along a straight line path, moving each point the same distance in the same direction. When you see a mapping rule that is showing a translation, you'll often see xy goes to x plus some number, and then y plus some number. That number doesn't have to be the same, but if you're adding or subtracting a number only, then you have a translation occurring. Similarly, the function rule is just f of xy equals x plus a number, y plus a number. Because translations are a type of rigid transformation, they still share the same properties of rigid transformations, but they also have some very special properties that just they have. For instance, translations never have any fixed points. A fixed point is one that does not move, and we said earlier that each point is moved along a straight line path in the same direction, and that's why there aren't any fixed points. Rotations always have one fixed point called the center of rotation, and reflections can have fixed points. All points move parallel to and the same distance as every other point. Remember that the symbol for parallel is this. If you were to connect two or more points on the preimage to their corresponding image points, you would see that those segments translated in the same direction, they're equal in length, and they are parallel to each other. Now we're going to do a few example problems. Write a mapping rule based on the given description. Translate xy up 4 units and left 7 units. So we know if we're writing a mapping rule, we're going to start with xy goes to. And so now we just have to see if anything is done to the x-coordinate and if anything is done to the y-coordinate. So if we're moving up 4 units, that is going up, and if we're going up, that is dealing with y values. So we're going to have y plus 4 because we're going up, so we're adding. If it said going down 4, then we'd subtract 4. And if we're moving left, that is dealing with our x values. And if we're going left, we're going to do x minus 7. So our mapping rule is going to be xy goes to x minus 7, y plus 4. If we wanted to write the function rule, you would just have f of xy goes to x minus 7, y plus 4. In this example, we're going to use the function rule provided to translate the triangle ABC. So to do that, there are 2 ways. So one way is to find the actual coordinates of A, B, and C and use the function rule. So A is located at 1, 1. So to find the coordinates of A prime, I add 2 to the x value and subtract 1 from the y value. So 1 plus 2 is 3. And 1 minus 1 is 0. For B, I do 4 plus 2 and 4 minus 1. And that was for B prime. And then C prime, I do 1 plus 2 and 4 minus 1. So now I can plot those points and I would have my image graphed as well. Another method for graphing the image of triangle ABC is to look at the mapping rule. So notice how we have x plus 2. That means that we're going to be translating right 2 units, and y minus 1 means we're translating down 1 unit. So basically, we're going to do right 2 and down 1. So if we just look at our points that are given here, we can just apply that. So we go right 2 and down 1. So right 2 and down 1. So this is going to be A prime. We're going to need some more tick marks here. But if I go right 2 and down 1, here's B prime. And then right 2, down 1 is C prime. And if you notice, those are the same coordinates we got. We found that A prime was at 3, 0, B prime was at 6, 3, and C prime was at 3, 3. So you have 2 ways you can solve. You can either use the mapping rule and find the coordinates and just plot those, or you can use the mapping rule and do like we did here where we just used the graph and plotted our points from there. Remember when we talked about properties of translations and we said that each point is moved along a straight line path, the same distance in the same direction? Well, let's just show an example of that where we connect our pre-image points to their corresponding image points. See how the lines in green are all straight line paths and they're the same length? notice that they are also parallel to each other, and we said that was true, that if you connected two or more points on the preimage to their corresponding image point, you would see that those segments translated in the same direction. They are equal in length, and they're parallel to each other. For example 3, we're given coordinates for A prime, B prime, and C prime, and the mapping rule. And so we know what we ended with. We know the image. So now we have to figure out the coordinates of the preimage. So how do we work backwards? So if you notice, I just wrote the mapping rule, and I was putting a spot for the preimage and how it went to the image coordinates. So we took some coordinates for A, we subtracted 7 from the x and added 4 to the y, and wound up at negative 6, 5. So we could think of it as what minus 7 gives us negative 6, and what plus 4 gives us 5. So if we think about that, 1 minus 7 gives us negative 6, so A must have started at x equals 1, and then 1 plus 4 gives us 5. So A must have been at 1, 1. And to just double check ourselves, we can do 1 minus 7 is negative 6, 1 plus 4 is 5, and so we know we did that correctly. Using similar logic, we can find our coordinates for B. So what minus 7 gives us 10? That has to be 17, because 17 minus 7 is 10. And what plus 4 gives us 9? Well, that would be 5. So B must have been at 17, 5. And now we just have to find the coordinates for C. So we have something minus 7 gives us negative 2. And 5 minus 7 gives us negative 2, so C must start at 5. And then something plus 4 gives us 2, so negative 2 plus 4 gives us 2. So those are our coordinates for A, B, and C. So we just used the mapping rule and worked backwards, and just thought about like what minus 7 gives us our image x value and what plus 4 gives us our image y value. But we really could have just reversed our mapping rule. So if we did x minus 7, y plus 4, to get back to where we started, we could just do x plus 7, y minus 4, and solve. So if you look at negative 6, and that's from A prime, so negative 6 plus 7 gives us 1, and then 5 minus 4 gives us 1. And so that's how we found A. For B, we do 10 plus 7 gives us 17, and 9 minus 4 gives us 5. And for C, we do negative 2 plus 7, which gives us 5, and then 2 minus 4 gives us negative 2. So that's another way you can think about working backwards. Either way is fine because they both arrive at the same coordinates. On the next two slides are the two questions you have to answer in the Google form for check-in for translations. Okay, so this concludes our notes on translations. Here are your learning targets for today. And as always, shout out to the people at Slides Carnival for these awesome resources we got for free. Thanks for watching.